In this video, we're going to look at two specific conjugate addition reactions. We're going to do the addition of amines and water to the alpha-beta unsaturated carbonyl. So first, let's look at the amine addition. So if we have a regular carbonyl, we have seen previously, we can react that with a primary or a secondary amine. And depending on what you start with, it's going to determine your product. So you would get either ene-amine or imine formation. For the unsaturated, the alpha-beta unsaturated carbonyl, again, we can react with primary or secondary amines. And what we're going to get are beta amino, so an amino group on the beta position, aldehydes and ketones, again, depending on what you start with. Now, these two reactions do provide a mixture, at least initially. You still have that electrophilic site at the carbonyl, even with the alpha-beta unsaturated version. But if the amine attacks that carbonyl carbon instead of in the beta position, that reaction is a reversible reaction. It's an equilibrium. So your equilibrium is going to shift, and eventually you're going to go to the more stable product, which is the beta amino aldehyde or ketone. So if we look at a specific example here, so we'll just look at methylamine. This is a primary amine. That amine group is going to attach to the beta position. And what you will get in the end oops, there's a positive charge up there, sorry, is that beta amino, in this case ketone. And this will be the sole product. Again, even though there will be some amine formation, that amine will revert back to starting material, which eventually will trickle into this final product. For the addition of water, this is also a reversible reaction, and it does favor the reactant side. So it's not a good lab reaction unless you can do something to shift the equilibrium towards products. It is an important reaction because it is very prominent in some biological processes, so it is one worth being familiar with. So again, if we have our unsaturated carbonyl, we're going to add water. We get our intermediate, which will then protonate to form our product. Now notice in this example, so my starting material, I threw on an extra carbon. And the reason I wanted to do that was to show you that if your alpha-beta unsaturated ketone or aldehyde is extended past that beta position, which it can be, what you're likely going to form is a chiral center. So I have a carbon here with 4 different groups attached. So it's something to pay attention to, especially if your question's asking you to draw all products. You will get a racemic mixture, and it's just something to keep in mind.